Okay, to simplify logic case, there is certain basics in mathematics that I think I'll go with it. I'll just try to solve this, and then I'll go with it as what as I'll keep bring them up. There are certain reminders that come from normal mathematics. So first, you have to understand what is called De Morgan's theorem. All right, De Morgan's theorem. De Morgan's theorem is very important when it comes to this aspect of the work. De Morgan's okay theorem, very important when it comes to what to this work. All right, first of all, if for any expression, I'm saying it in my own language now, in the way I understand it, okay, if for any expression there the O symbol is replaced with the N symbol, or vice versa, okay, and the inputs are inverted, the result is the original, is the inverse of the original statement. That is how I understand it. That's how I think it's easy to remember. All right, so what are we saying here? Let's say we have an expression. Let's take an example of an expression. The basic ones, A or B. Okay, we are saying if this is replaced by that and the inputs are inverted, the result is the inverse of the original expression. Okay, let's take the other one. Okay, let's say we are there and we say if that is replaced by that, the end is replaced by the O, and the inputs are inverted, the result is the inverse of the original what call this statement. Let's prove these two. Okay, let's say A, B, and we say not, this is proof, not, okay, there's many ways to prove it. I could use the truth table to prove this. This is proof, not, okay, and I'm going to say, what are we going to do here? We're going to change the what? We're going to change that end to an O, invert the inputs, okay, and the result is the what? Inverse of the original. Okay, so now what are we saying here? If the inputs were, we took this, the inputs were A, not A and not B, we changed that to a plus, and we are saying that if we invert those inputs, the result is the inverse of the original. All right, let's see what we mean. We are saying here double negation. We learned in the previous one of the exercises previously that double negation falls away. A or B. Okay, now let's take the other one. And we change the O to the end. We take the inputs, we invert them, or B, sorry. We not B, and we invert it. The result is there. Let's look at this. A, what? Because double negation falls away. All right. So remember that when you started off, we had A or B. When I started off, I had A or B. So after I did what I did, if I'm proving it, it must take me back to A or B. There, we are back at A or B. We started off with A and B. And then now, where did you end? I said, if I had A and B, then I inverted the inputs, then the result will be the inverse. I came and inverted. But when I started off with A and B. So I went back where I started, and I went back where I started. So this is obviously true. Now, what am I saying here? I'm basically just saying, is this language really necessary? Nah. The long and short of what? The long and short of De Morgan is break the line. The line. Oh, not that line. The line change the sign. Okay. What did we do here? We broke that line. The line became two pieces, one on A, one on B, and we changed the sign from that to that. And then O, join the line. Join, I'm already on change in my brain. Join the line, change the sign. Same thing, all right? Because if you go that way, I actually joined that line and I changed the line. If I go backwards, I'm actually joining the line and changing the sign. So this is De Morgan's theorem. It is very handy when it comes to a lot of our solutions here.